All right, one last problem. This is exciting. I've got two radicals. Go ahead, SYH, but we're going to do this anyway. Okay. Step one says to do what?
Isolate.
Isolate a radical. So what do I need to do here? When I say isolate a radical, that means to get one radical by itself. Don't have them all on one side because that's going to go very badly for you.
So you add the square root of x to the other side?
Yeah, you're going to want to do that.
3 equals square root of x plus 1.
The square root of x plus 3 is equal to, be careful how you write this. This is the square root of x plus 1. And you may say, could I also write 1 plus the square root of x? You could. That's the same thing. Addition is commutative.
Then you square both sides.
Right, and this is where it gets super tricky because you're not just squaring a binomial on the right side, you're squaring a binomial that has a radical. The left side is easy. That's just x plus 3. The right side, though,
Well, x, it should be x. I mean, x binomial.
think about what you're doing here. You're trying to take the square root of x plus 1 times the square root of x plus 1. If you FOIL this, what happens when you FOIL? The product of the first terms is what? Well, it's the square root of x squared, which would just be x. What's on the outside? 1 times the square root of x?
1 times square root of x. It's just the square root of x.
Okay, when you go inside here, what do you get? 1 times the square root of x is still the square root of x, right?
Yeah.
And what's 1 times 1?
1. That's weird.
It does seem kind of weird. And this is where I like using the special product because it's a little bit faster, a little bit easier. So here I just have x. What's the middle stuff, though? When you combine this, what do you get?
2 square roots of x.
2 square roots of x, and you got the 1 at the end, right? Now, how many radicals did you start with? You started with 2 radicals in the equation, right? How many do you have now? You just have 1. So the problem, we're getting closer to where we need to be. So step 3 says if radicals remain, you got to go back to step 1 and do it all over again. So step 1 says get a radical by itself. How do I do that?
Like rerouting here.
I've got to move the x over. I've got to move the 1 over. So what does my equation look like now? 2 is equal to, well, because those guys reduce, 2 square roots of x. Now, before I square both sides, I don't have this radical completely by itself, so what could I do here?
Divide 2.
Right, if you divide both sides by 2, then you get 1 is equal to the square root of x, right, because the 2's would reduce here. You're looking at me like 2 over 2 doesn't become, how did you get 1?
You're supposed to square both sides or something again.
I'm not done yet. See, if I square both sides, a lot of times students run into trouble over here. But now, that I've got this radical completely by itself, I'm going to square both sides. So what do we have?
X equals 1.
1 equals x or x equals 1. Does it check out? Plug in 1 up here. What do you get?
1.
I get 1 plus 3 is 4. Square root of 4 is 2. Minus plug in the 1 here.
Yeah,
2 minus 1 is 1. All right, so everything checks out here.